Hello everybody. Today we're going to take a look at some 4-digit dividend division. You guys are getting really good at using both the place value chart and the area model for division. I am super proud of you guys. So we're going to keep pushing it a little bit and go into 4-digit division. But you guys are ready. So let's take a look. We've got 4,325 divided by 3. And I'm just going to do a sort of an extra added little step. Not sure if you guys remember the fun trick to see if something is divisible by 3. Or in other words, I want to know, is 4,325 a multiple of 3? And do you guys remember that fun little trick I told you where you can take the digits of your number and add them all together to find out if they're divisible by 3? Do you remember that? You add them all together, and if you end up with 3, 6, or 9 as your answer, then you know it'll be divisible by 3. And I'm just going to do this step to see from the start, will I need or will I have a remainder? So I'm just going to add all these together. 4 plus 3 is 7, plus 2 is 9, plus 5 is 14. And then if I have 2 digits, I'm just going to add those 2 digits together and I get 5. So right now, I already know I am going to have to end up with a remainder because it didn't end in a 3, 6, or 9. So it's just an extra little piece. But now I know I'm going to have a remainder, so I want to kind of pay attention to that. So I'm still going to set up a number bond because a lot of you are still liking to use that to break up your numbers, which is perfectly appropriate and fine. So as we move to thousands, once again, I just want to remind you, sometimes it works out nicely that if you just break it up by place value, it's nice and divisible. In this case, is 4,000 easily divisible by 3? It's not, or maybe you aren't sure. So you aren't going to be able to just break it up into 4,000 and then 300 and 20 and 50. So you're going to have to be thinking about what are those numbers that we can use. So the first thing that comes to mind, since we're in the thousands, I'm going to go as big as I can into the thousands. And since I'm dividing by 3, I'm going to go with 3,000. I know I can do that because I know if I divide by 3, it's going to give me 1,000. Now I have 1,325 left, and sometimes I like to just kind of put it up on the side or in the corner to keep track. Now, I see that I can't do 1,000 divided by 3, so what I'm going to do, remembering back to last week's lesson, is I'm going to shift over 2 place values, and now I'm going to think of this as 1,300. I'm going to forget about the 25 for a minute. And if I look at 13, I want to see how close can I get to 13 with 3s. So 3, 6, 9, 12. I can get to 12. So I know I can do 1,200, right? Because we know if we can get to 12, then we can get to 1,200 or 1,200. That's going to be divisible by 3. So now I've used up 1,200. And I have 125 left, so I'm just kind of keeping a running track of what I've got left. And look at that, I've got a 12 again, because I can't do 100 divided by 3, but I surely can do 120 divided by 3, right? And then I have 5 left, and remember I said I knew I was going to have a remainder? Well, 5 isn't my remainder, because remember, if your remainder is larger than your divisor, then you can still divide. But I do know I can fit one more 3 in, and then I'm going to have a remainder of 2. So already I feel like I'm on the right track because I knew I was going to have a remainder left. So I've divided all this up into parts that I know are going to be easily divisible by 3. Now I'm going to set up my not my place value chart, my area model. Again, I want you to think about size, folks. I don't want this to look like 3,000 and then this to look like 1,200. We want to make sure a representation is accurate. So I'm going to put this part, this chunk, maybe a little smaller just because I want space, as my 3,000. And we know I'm dividing by 3. I'm going to break this part up into the 1,200, and maybe slightly longer. And then this part's going to be the 100. You know what? I think I can go even longer with that, guys. And then this part's going to be the 120. And then this part's going to be my 3 with my extra little 2 left over, okay? So I'm going to put my partial quotients down here, and I would like you all to start getting in the habit of writing your partial quotients. So I've got the problem here of 3,000 divided by 3 plus I'm going to do 1,200 divided by 3 plus 120 divided by 3 plus 3 divided by 3. And those are going to be my partial quotients. So if I go ahead and start solving, if I have 3,000 divided by 3, well, I know 3 divided by 3 is 1, right? So this is going to be 1,000 because we're in the thousands place. So I know this section is going to be 1,000. Now I'm going to do my next one, 1,200. Now remember, I'm looking at the 12 basically, because now I've got zeros here. And this is just the shifting of place values, so I don't have to really worry about those. I can keep on with my basic fact. 12 divided by 3, 3, 6, 9, 12, that's going to be 4. So I know I'm going to have 4, but then I've got 2 zeros to shift over that place value to the hundreds, so I'm going to have 400. If you end up with 4,000, I want you to think about that. Would 1,200 divided by 3 equal 4,000? And if you go, whoa, that doesn't make sense, you know you've shifted over by your place value one too many. Okay? Now, if we know 1,200 divided by 3 is 400, we also know 120 divided by 3 because we still have that basic fact of 12 divided by 3, which is 4, but then we've got our 0 to shift our place value over by 1 because we're going to talk about tens. So we've got 4D, and 3 divided by 3 we know is a 1. Whoops, my plus sign is a little wonky there, guys, sorry. So now I'm going to add up all those partial quotients on the sides here, 1,000 plus 400 plus 40 plus 1, and you get 1,441. It kind of writes itself almost, doesn't it? Okay, and I did it a little close, so you guys just keep in mind what the mistakes I've made and see if you can avoid them. Uh-oh, better try that again. And just try to write your partial quotients down a little bit further so that you have enough space to be able to label your full side length as 1,441. So our quotient is 1,441 with a remainder of my 2. Okay? And you can check your work by using your multiplication, right? So we would take 1,441 times 3 and then add our 2. Okay? So if I put my next question down here, but I'm going to move it. So we would do 1,441 times 3 to check our work. So I can do 1,000 times 3, which I know is 3,000. 400 times 3, which I know is 1,200 because I know 4 times 3 is 12, and then shift it over by those 2 place values. I know 4D times 3 is 120, and I know 3 times 1 is 3. And if I add all those up, 3,000 plus 1,200 plus 120, whoops, plus 3, I will get 4,323, and then I have to add my remainder of 2, and I will get 4,325, which is exactly what we started with. And recognize here, guys, that this ends up looking exactly the same. 1,000 times 3 equals 3,000. Look, 1,000 times 3 equals 3,000. 400 times 3 equals 1,200. 400 times 3 equals 1,200. So you'll see as you do your partial products to solve it, it's going to end up looking very similar to your area model. Heads up, I'm about to sneeze, folks. Excuse me. So let's just take a look at another one really quickly, just to make sure you get the hang of it. And this one's going to be nice because a lot of it you can go by place value. So we're dividing by 2, and automatically I'm going to take a look and see, am I going to have a remainder? And remember, the trick is you only have to look at the ones digit. And if it's an even number, we know it's going to be divisible by 2. So in this case, I know I'm not going to end up with a remainder. So I'm going to start my 1,254. And in this case, my place value is handy because I know 1,000 can be divided by 2 or cut into half, right? I know 200 can be cut in half. Now I have 54. Now, a lot of you might wonder, like, I don't know if 50 can be cut into half, but I know 50 can be cut into half. And I know that for a couple reasons. First of all, it ends in a 0, and I know that any number that ends in a 0 is divisible by 2. I also go back to my quarters. I use money a lot, guys. And if I think of 2 quarters makes 50 cents, then I know what half of 50 is because I'm just going to look at 1 quarter. So I'll know that half of 50 is 25. And then I have 4. And I know that's divisible by 2. So sometimes you can just break it right up by place value and you'll be set. So we're going to go through this pretty quickly here because I think you guys would know this one. We've got 1,000 here. We've got 200 here. We've got 50. And we've got 4. So I'm going to label my side length. I'm going to start writing my partial quotients. 1,000 divided by 2 plus 200 divided by 2 plus 50 divided by 2 plus 4 divided by 2, right? And then we're just going to go ahead and solve. So 1,000 divided by 2, well, I know half of 10 is 5. Half of 100 is 50. So half of 1,000, 500. I know half of 200 is 100. 2s are great because you can just think of it as half of something. I know half of 50, as I already explained, is 25, thanks to money and quarters. And I know half of 4 is 2. So now I'm just going to add up all my partial quotients. 627 is my quotient. No remainder. And I'm just going to make sure I label the bottom here. 627. And again, I'm going to ask you to check your work. So we do 627 times 2. So I'm going to do 600 times 2 is 1,200. I'm going to do 20 times 2 is 40. 7 times 2 is 14. And I end up with, if I add all of those, 1,200 plus 40 plus 14, and I'm going to get 1,254. Now notice in this one, I got the correct dividend, right? But my partial products doesn't quite look exactly the same as my partial quotients. So just recognize that, okay? Because what we did is rather than breaking the 600 up into a 500 and a 100, I just did it all in one, right? So you are going to go ahead and try some 4-digit dividend division today. And you're going to make sure that you show it on a area model and check your work. Let me know if you need any help, and good luck.